I'm thinking about sensation and pain and awareness and central nervous systems and sensory motor systems, and how these things are very different in different life forms, and maybe over evolutionary time they're different. Because just because an animal or a creature or an entity, an organism of some kind can move, doesn't necessarily mean that it's, well, obviously it's not necessarily mean it's sentient or conscious. But I'm just trying to think through what the implications of that are. Because some animals, or some organisms, entities, life forms, like amoeba, they can move, but they haven't got any sensory organs. They haven't got a central nervous system. If an amoeba is in a, in a medium, in water, its cell wall can detect. It sounds like just the chemical composition of its cell wall. It makes it capable of recognizing concentration gradients in the liquid, which would signal, the presence of something that can be eaten. But it doesn't. But there's no sensory thing. It's just purely biochemical. That part of the cell wall that's nearest to the strongest concentration of this nutrient would soften by purely biochemical processes. The cytoplasm inside the cell would flow into that area of softened cell wall, making it protrude. The back end of the amoeba would kind of follow it in, and the effect would be of the amoeba putting out these pseudopodia and moving towards where the food was. That's what it would look like, but it's really purely biochemical. And you get the same thing with plants, don't you? You know what I mean? Sunflowers, they follow the sun through the day like that. They're always looking towards the sun, but it's not like they can see the sun and think, oh, there's the sun, I must follow that through the sky. It's purely biochemical. There's the chemistry of the stem is such that it reacts to the light and changes the orientation of the plant accordingly, so it's always facing the sun. So it's movement, and it's intelligent movement, if I can characterize it as that. But it's purely biochemical. There's no central nervous system or anything like that, or sensory thing going on. Slightly more complicated organisms like flatworms or something really simple, they do have the beginnings of a central nervous system. They are able to detect the environment and move accordingly, move away from toxins, maybe move towards nutrients. And it's not purely biochemical in that case. There is the beginnings of some musculature that is triggered to do appropriate things in response to certain sensory input. But it is like a knee-jerk response. It's not a cognitive process in any sense. They haven't really got brains, I don't think. I'm pretty sure they haven't. It's a more complex set of reflex arcs, but it is just that. It's not biochemistry, it's reflex. Then if you go into the upper complexity a bit more and get some really simple fish-like creature, not even a fish even, but I don't know, maybe like an eel or something like that, something really simple. They've got some central nervous system, and they've got a little bit of a brain stem, just enough to give positive and negative evaluations of stimuli, but not enough to do anything intelligent with anything that we would think of as intelligent with that. Not much more evolved than a sandworm, really. It would just allow it to swim in one direction as opposed to another, to be able to make some kinds of vague predictions about which might be the best place to go, but not in any kind of thoughtful cognitive way, just in terms of just to the routine processes that they go through. But there's still no sensation there, I don't think. There's no sensation there. It's only when you get slightly more complex, probably something like a frog, I would guess, although I'm just plucking a frog out of the air, so to speak. I think once you get to something like that, it's got the beginnings of a brain, a little bit of brain there. It can't do much, but it can probably register that positive and negative valency, the good and bad things of the environment, the toxins and nutrients of the environment, the predators and the prey. It can start to register those not just as not just as reflex arcs, but as pains and pleasures. It would probably start to feel the ouchy thing going on there, or the ooh-ah thing going on there, and would move towards the ooh-ah and away from the ouch. You know, that would be the carrot and the stick that biology has provided for Mr. Froggy, I guess. And then only once you get past that, to the mammals, I guess, and probably not until you get to the primates, is that ouch and ooh and ah made more complex by fully fledged what we might call rational processes, things like language, but also, you know, other kinds of reasoning processes. The kind of thing which would make you say, yes, it hurts, but I'll do it anyway, or oh, it's nice, but I better not do that. You know what I mean? If you haven't got higher reasoning, you've got no way of avoiding temptation or of allowing yourself to experience pain for the greater good. Yeah, so feeling came first. Actually, yeah, feeling didn't come first. Movement probably came first, then sensation, then evaluation of sensation, then pleasures and pains, and then reasoning. That makes sense.